It's all new information for you. You've never heard this before. Okay, who knows what a soccer ball is? Perfect. That's all you need to know. Okay. With this, there's some rules with soccer, and you know, there's some rules on. Here's let's say red. This is Mo Salah from Liverpool, and he's the forward for Liverpool. These are the back, say, defenders for Chelsea. Now, can Mo Salah just kind of hang out right next to the goalie and just hang out there, just wait for the ball and push the goalie out of the way and it goes in? No. What's the rule that says you can't be all the way kind of cherry picking over here? What's the rule? Offside. So here's Mo Salah. Here's kind of 0. You can see this is kind of a coordinate grid here, coordinate plane. Now, Mo Salah is right here. And where is the limit? Tell your partner, and maybe use these numbers here to say, where is the limit where Mo Salah can be if we have here Robertson about to pass the ball? Okay? Tell your neighbor. 5 seconds. What do you think, even if it's an idea or I don't know?
Or even further away.
Perfect. All right. All right. Let's see. Genevieve, help us out. What did you and your partner come up with?
We said negative 20 to negative 25.
Like it. So here's the deal. You ever seen now that VAR and they'll like show the field and kind of put the line there to see if you're on offsides or not, right? Yeah. So would you agree that Mo Salah could be from here at negative 20 all the way? He'd be a bad forward if he was hanging out on his defensive side, but he could be anywhere where I just put this arrow. You guys agree? Yeah. At the moment when it's kicked, the restriction what we're talking about is what values are included in the function we're dealing with. The restriction for the x-axis, right? The x-axis from left to right is from what to what? What's the lower limit for that? What's the lower? So lower would be towards the negative values. Negative 20. And what is the upper limit for it? 50. Okay? Now I'm using these open brackets just because Math 1 basically uses open brackets. I'm just basically asking you, where is the player located? Where can they be? Where can they play? They can be from here because offsides if you're past it, all the way. He could be hanging out over here looking at the flag to make sure that they match. He could be running back and forth. He's like, they're the same flag. But that would not be a helpful forward, right? Where's he supposed to be? Up here scoring goals. But he could be over there. Okay. Now, this is a coordinate plane. This is 0 moving up to 25 to 50 along my y-axis. So, and it goes down, it's negative 25, negative 50. It goes up, let's say it's 50, 60, 70 up there. Is there a limitation on where Mo Salah can play as far as up to down? No. What if Mo Salah was playing and he ended up way up here? He went up into the stands. He went to the stands to get, some popcorn or something. Cotton candy. He loves cotton candy. Can he be out here, out of bounds, and take a pass? No. If he's out of bounds and the pass goes to him, what happens? It's a throw-in, right? It's a throw-in. So what is the limit? Can Mo Salah be down here? No. Can he be right here? Yes. So it's between 0 and what? 50. Okay, what we're going to learn next is, as far as the x and where they're allowed to be, that's called the domain. By the end of the lesson, you'll have these done. As far as the y values, where he's allowed to be, that's called the range. So we're talking about left to right, where can he be? Up and down, where can he be? And those are the two concepts we have to do. Does it make sense where Mo Salah is allowed to play right now? At the time of the pass, he has to be in bounds between his goal and these defenders or his offsides. Okay, so we've put a restriction on where he can play. Okay, thumbs up, sideways down for knowing where Mo Salah should be. Okay, that's good. That's good work. All right, now let's relate that idea to some graphs, and I'm focusing for this standard. I'm focusing on exponentials or growth decay problems. So we're using these kind of problems. Okay. Now let's look at this. Restrictions. This is 141, by the way. This is the last lesson in Unit 1. We've already got through 1/6 of the class. It's amazing. Yeah. So the restrictions. What values are included in the x values? What values are included in the x values? That's our domain. What values are included in the y values? That's going to be our range. So we have to assess one at a time. If I'm looking for the domain, I'm just saying, well, what about the x values? What are included? Okay. Let's look at our domain for this. So we're going to find it from the graph. Okay, from the graph. X values. This is our lower limit, lower. This is our upper. Okay. So as far as the lower limit, let's look at x values is talking about side to side. Where is my lower limit? Lower limit's going to be over here. Does it keep going? Yeah. Keep going. Keep going. All the way to negative what? Negative, what's like if you keep going forever? Infinity. So there's negative direction of infinity. That's the lower. Now this is exponential, so we know this is growth. It's going up. It's going up, so it's growth. Does this keep going up and over? Yeah, so if I had my laser here, I know that it goes from negative infinity, it comes this direction, it goes up. It's going up, but it's also going what? It's going over as well, and probably steeper because it's exponential. But it is going to the right, and it doesn't stop. It keeps going forever, so what do we call that in the positive direction? Okay. And I'm going to let you know, for exponentials, this is probably key. This is key. When I say something 4 times and draw a key, you know that it's important, probably for the... So exponential functions are always going to have that domain in Math 1. When we get to Math 3, it's going to be some different things.
So that is never going to be straight up.
It does never get straight up. Because think, if x is time, right? If these are bunnies,
Oh, yeah.
you can have the bunnies at 5 weeks. You can have it at 20 weeks. At 1,000 weeks, you can figure out. It's going to be way up there, though. But it still is going up and over. Good thing to point out. Thank you. Let's look at the range. Range is talking about? Why? What limitations? Like most solid, he has to stay in bounds. So we're looking to see this function. Tell your partner, what do you think the lower limit is? What is the low, and then what is the high? So what is the low for this graph? For our y values, we're talking about up and down. Question? If you don't know, my question to you is, does this blue function ever touch this negative value of y as negative 10? No.
Not at all. I didn't solve this.
No. Okay, we got some ideas. Any volunteers? What's the low limit, guys? 0. Does it ever go below this line?
No.
You just have to look at the graph. It's 0 to what?
Infinite.
Infinity. Positive infinity. We want to distinguish positive to or negative infinity. Even though positive infinity is infinity, still, let's go positive infinity. Because you're going to see that over and over. Okay. All right. Let's do this one. Let's see where we're at. And then we'll look at from an equation. So one more graphing here. We already know that the domain, talking about my x values side to side. How about our lower limit? Lower limit is? You can also remember the key. What is my upper limit? It goes down. It keeps going down. It keeps going down. Negative infinity to the upper. Positive infinity. Here's the deal. It goes down. But could I find the number of bacteria at 10, at 20, at 1,000? It would be way down there. But we know also that exponential functions, the domain is going to be the same. It goes both directions. It just goes way up there. How about the range? Tell your neighbor, what is the range, which is the main thing we have to find for this. What is the up and down? What is the lower limit? What is the upper limit?
upper limit.
It wouldn't be the upper either.
All right. Hey, what's the lower limit? Where does it go? Yeah.
The lower
Okay, hold up. And then what is the upper limit? Does it go up here to 10? Where does it go to? 4. Does it ever touch 4? No, it's getting closer and closer and closer and closer. It never touches it. We're going to see that with our equation. Okay. Finding the domain and range from a graph. Thumbs up, sideways, down for this. Finding it from the graph. Finding it from the graph. I like that you added the pinky. It's good. Question? Do you want another example?
Yeah.
You can always have another example. You just got to ask. So thanks for asking. Someone else needed it. Let's see. How about this one? Oh, we already have this here for the next problem. Let's use these. Okay. So the first step is to you gotta put this to memory that domain is x. I'll keep reminding you, but you'll get it. You'll make some connection there. One thing to think of it is x comes before y in the alphabet. D comes before R in the alphabet. I like to make a mnemonic device to remember stuff because rote details are hard to remember. Okay, so our x values are talking about left to right. What is our lower limit? Where is this function going? It keeps going forever. So I'm going to put negative infinity because I know to the left the lower limit is keep going. It keeps going in that direction. How about the upper limit? So to the right it keeps going up. Yeah, but it keeps going to the right. And this is for, those are for all exponential functions. They're going to kind of follow that path, okay? So how about the range? Tell your neighbor, what is the lower limit for the range? Good. Nate, help us out. Lower limit?
-7.
How'd you know that? Tell me. Describe how you know.
It doesn't go past the 7.
It doesn't, right? It goes and it kind of like evens out right there at 7. It's getting closer and closer. It will never touch it. And that's kind of a crazy idea to think about. It gets closer and closer. Okay, and then what is the range, the upper limit? Okay. A little better? 1% better? More than that, right? Okay, now thumbs up, sideways, down for finding from the graph. Yeah, I like it. That's good. All right, we got one more thing to do. You already know how to do this. I just have to show you the little extra step you got to do. So I'm going to get rid of these. And get rid of that. Get rid of this. All right, last part of this lesson. We're going to graph this using a table. So what is our favorite thing to plug in?
0.
We love plugging in 0 because with 0, it's always the initial amount. Time is 0. Let's do 1. But I also want to do this. I want to do -1. I want to do -2. So let's go ahead and plug in 0. And this is not totally necessary because 3 to the 0 is 1 times 2 is 2. So when I plug in 0 for x, I get 2 for y. 2. Let's do 1. 1 is also pretty quick because it's 2 times 3 to the first. 3 to the first is 3 times 2 is plus 2 is 5 times 2 is 6. So we'll get that 6 right there. Let's see what's happening. I'm curious. At 0 for x, I'm at 2 for y. That makes sense. At 1 for x, I'm at 2, 3, 4, 5, 6. 6 for y. Let's see what's happening on the other side. -1. So y is equal to 2 times 3 to the -1. Negative exponents aren't that fun. You could work this out on your calculator if you wanted. You do 3 chevron raised to a -1. Okay. But if you have a negative exponent, the other thing to do is, who remembers this rule? I don't know if you learned that. Did you learn it? Use a calculator if you need to, but this is how we solve. Say again?
Do you just multiply it across with the exponent?
Not quite, because it has a negative exponent. We always deal with negative exponents right off the bat. We want to deal with the negative exponent because you can't multiply 2 times 3 because the exponent would have to happen first. PEMDAS. So this is what happens. You take that 3 to the first, or negative 1, you put it underneath, and then it becomes a positive 1. If you move the term with the negative exponent to the other side of the fraction, it becomes a positive exponent. So we know that when x is negative 1, y is 2/3. Or we could say, 0.667, repeating, 0.66 rounded. And then the last thing I'll do is negative 2. Let's see if we can get it with this one. Negative 2. I want to deal with this exponent, so which term am I going to move? The 3 to the negative 2. We get 2 over 3 to what exponent? Positive 2. You just move that term, and the positive negative changes for that part of it. So this is 2 over 9. And what is that? 0.2.
0.222.
Yeah. 0.222 repeating. So let's see what's happening. At negative 1, it's at 0.667. At negative 2, it's at 0.22. Where do those points look like they are going towards? So far, I have this part. Where is this? What's the lower limit for my y is going to be?
0.
Well, I'm talking about my y values. So I know that the upper limit for my y values is going to be infinity. How about as it comes down, what number is it getting close to?
0.
It's getting close to 0. Now, we need to double check. So I put these values in here, but I could have plugged in negative 20 to see what's happening way down there. I'm going to go ahead and just plug in one last one, negative 10. And see what happens at negative 10. So you're plugging in whatever values you want. I might actually next time just plug in these 3 and then one that's way out there to kind of see what's happening way out there. Okay, let's see. Y is equal to 2 times 3 to the negative 10. We're going to move that to the bottom. 2, 3 to the 10th. 3 to the 10th is a huge number. But it's on the bottom of that fraction, so it's going to make us 3 raised to the 10. Is 59,049. So 2 divided by that, 2 divided by your answer, y is equal in this case to 0.000033. Is that really close to 0? 0.0000338 is really close to 0. It's really close. So when I'm out here at negative 10, I'm really close, so I know that this is continuing. It's getting close to 0. It'll never touch. If I did negative 10,000 way over here, it still won't be to 0. It'd probably be 0.00000000000000000. You can't even say it after you say it 10 times. 2. It'd be really close, but never touching. Sometimes math blows your mind that way. How can we be moving towards it and never touch it? It's weird. Thumbs up, sideways, down, doing it from an equation. Who needs to see one more like that? Crickets. Okay, it's mostly thumbs up, so if you need additional help, I'm going to help you during classwork. You guys have your classwork on Edmodo. You can always see what your assignments are on Edmodo. But I'm going to let you... how much time do we have in here? We've got 11 minutes. I'm going to open up that table and that table. Only as many that seats that are available. Back 2 chairs in the back table I'll open up. Come around in about 5 minutes. Let's see a couple of these done. Look on Edmodo. All right, don't forget to subscribe.